To all, in this video I am going to explain about electrical machines lab 2 experiment number 8 no load and blocked rotor test on 3-phase induction motor. Okay, to conduct no load and blocked rotor test for a given 3-phase induction motor and draw the circuit diagram and equivalent circuit we are going to do in this experiment. Apparatus required voltmeter 0 to 500 volt MI and 0 to 50 volt MI, ammeter 0 to 5 or 0 to 10 amps MI, 2 numbers, and wattmeters 10 amps 500 volt 1, 10 amps 75 volt, UPF unity power factor. There are two things we need. Okay, and this is circuit diagram for open circuit. We are not going to give any load to the circuit. We give the supply to the 3-phase induction motor, and here the W1 and W2 are measure the no load power, and A1 and A2 is used to measure the no load current, and V is used to used to measure the supply voltage, that is line voltage between R and Y. In this diagram that brake drum, okay, blocked rotor test. So before starting the experiment, what we should do here, we should tighten that brake drum with the help of T1 and T2, and once we switch on that one, the motor should not rotate, like that it should be blocked. To the rated current we should vary using the auto transformer. Corresponding ammeter 1, ammeter 2 values we should take, and voltmeter value we should take, and wattmeter W1 and W2 we should take. We should take more cautions when you go for blocked rotor test, because the motor is not going to run. At the same time, the current value will increase. Okay, so we should go the rated current, then we should stop that. Corresponding that voltmeter wattmeter readings we must take. Okay, this is a procedure for open circuit test and blocked rotor test. Connections are made as shown in the figure. Keeping the 3-phase auto transformer voltage is 0 output position, the supply switch is S1 is closed. By varying the 3-phase auto transformer, the rated voltage of 3-phase induction motor is applied. All the meter readings are noted down. To stop the motor, the 3-phase auto transformer is brought back to its initial or 0 position. Okay, for blocked rotor test, connections are made as shown in the figure. The brake drum of the induction motor is blocked from the rotation of the tightening the belt. By keeping the 3-phase auto transformer voltage in 0 output position, the supply switch is closed. By operating the 3-phase auto transformer very slowly, a low voltage is applied such the voltage rated current of the induction motor flows in the stator winding. All the meter readings are noted down. To stop the motor, the 3-phase auto transformer is brought back into the initial position. Loosen the belts of the brake drum, then open the supply S1. Let's see the experiment demo.
No load test and blocked rotor test on 3-phase induction machine. For that, some of the equipments like auto transformer we are using, DOL we are using, 2 ammeters, ammeter 1 and ammeter 2, and 2 wattmeters W1 and W2, and supply voltage measuring voltmeter. Okay, here we have RYB. Okay, RYB is a 3-phase, so the RYB is connected to RYB of the 3-phase auto transformer. Okay, that's the input for the auto transformer. Here we have 3 RYB. There is the output of auto transformer that will be connected to the meters. Okay, first here we are connecting RY to the parallel to the voltmeter, this one, and this ammeter A1 is connected through this one R. Okay, the R phase is connected through the ammeter A1, and B phase is connected to the ammeter A2, and wattmeter W1 is connected between R and Y. Wattmeter W2 connected between Y and B. Now we are going to start the DP, DT or MCB switch. Once we switch on this one, we must switch on the DOL. Okay. Then increase the voltage in that auto transformer up to 380 voltage, because the voltage what we measuring here between the line, okay, line voltage R and B line or R and Y line. So the voltage should be 380. Here we connected to the 600 range. Okay, so upper value we should take. Now the voltage 380 is given. The corresponding ammeter A1 value we should take. The wattmeter W1 value we should take, and ammeter A2 value we should take, and W2 wattmeter values we should take for no load test. Okay. Once we complete this one, what we should do? We should increase the current of this one up to 8.2 amps. That's the rated current for the blocked rotor test. What we are going to do? We are going to block this one up to that 8.2 amps. Then switch off. First we must block that drum. Okay. Drum should not run. Like that, we must fix it. After that, we must switch on the switch DOL starter. Here, one important point, we should check the value of current should not exceed 8.2 amps. Okay, now we are giving the supply voltage. Okay, so that rotor is blocked, so rotor will not rotate. We can see the current value increasing. Okay, the current value corresponding voltage value we should measure should not go beyond the 8.2 amps. Once it reaches then corresponding values of wattmeter, ammeter to wattmeter to and that multimeter that is used for voltage. You should measure these things. Then reduce the voltage of auto transformer to the minimum position. Then switch off the DOL starter and switch off the MCB. And once you completed, you must release this load.
Open circuit test will get the 380 volt as the supply voltage, and current will get in the range of 1 amp and 2 amp, and corresponding power 200 watts will get. Okay, for short circuit will get more current than the voltage will be very less. For the 60 volt or 70 voltage will get the ratings. Okay, construction of circle diagram. Proper scale we should take 1 centimeter equal to 1 amp if selected. Vector 00 dash representing no load current I0 drawn. Angle of pi naught with respect to y axis. At point 0 the line O is drawn parallel to x axis. Vector OA representing ISN is drawn at an angle of pi SC with respect to y axis. Vector OA is joined, which represents the output file line. The output line of OA is biselected for the. Okay, similarly with as a center for the same radius of arc is drawn OA dash. The intersections of the arc on either side of OA dash are joined. This line gives the perpendicular bisector. Let the perpendicular bisector cuts the horizontal through OX at point C, which C is the center of OC as radius as a semicircle circle drawn, which passes through the point A. From point A perpendicular line AB is drawn. Y-axis, that vertical line AB represents power input, a short circuited. Okay, so AB in centimeters. And these are the calculations for the finding the values of cos phi and cos SC, short circuit voltage, ISN, and WSN, and power scale we should take. Okay, these are the calculations. Again we should do the circle diagram, and this will be the circle diagram, model circuit diagram for this experiment, and this is the actual circuit diagram for the values what we got. Okay, and hence determine the circle diagram of three-phase induction motor by OC and block rotor test are done. Okay, some of the Viva questions which will be important questions for this experiment. Thank you.